Hello my friends, and welcome back to the You Can Do TV channel. The production of laminated timber is a high-tech, labor-intensive process that involves multiple stages to create high-quality construction materials. The process begins with the careful selection of pine logs by forestry experts, ensuring that the wood meets the necessary characteristics for production. First, the logs are cut into billets, which are then dried to a moisture content of 12 plus or minus 2% to prevent warping and ensure durability. After drying, the billets are calibrated to ensure uniform size and checked for defects. Any imperfections are carefully addressed. The next step involves bonding thin laminates together using small dowels, ensuring the planks are well joined. The boards are then calibrated again to refine their dimensions and are bonded flat, ensuring strong adhesion. After bonding, the billets are planed to smooth their surfaces, and a protective compound is applied to prevent moisture damage and pest infestations. The ends of the billets are then trimmed to the correct length, and precise corner joints are cut to fit. Technological holes are drilled for further assembly processes, and the corner joints are covered with protective compounds to ensure the long-term stability of the material. This process results in laminated timber with superior strength, high durability, and resistance to warping and cracking. It is ideal for applications where high-quality building materials are required. The process of manufacturing structural plywood components begins with selecting natural wood, such as pine or birch, from sustainable forest sources, then cleaning the bark and checking for defects before cutting to the appropriate size. The wood is sliced into thin veneer sheets, 1 to 3 millimeters, using a rotary slicer, then dried in an industrial oven to reduce the moisture content to 8 to 12%, ensuring no future shrinkage. The veneer sheets are then layered in a cross-section pattern, with the wood grain perpendicular between the layers and coated with specialized glues such as phenol formaldehyde or melamine urea formaldehyde, before being put into a hot press at a temperature of 120 to 150 degrees Celsius and a pressure of 1 to 2 megapascals to form a solid plywood panel. After cooling, the wood panels are precisely trimmed, CNC machined to create grooves, holes or joints for structural components such as beams, columns. The surface is sanded, coated with waterproof, fireproof, or decorative coatings depending on the application. The products undergo bending strength, load-bearing, and dimensional stability tests, according to standards such as EN 636, then are carefully packaged with shrink film and protective materials, ready for transport to the construction site or warehouse. This process combines modern technology and strict controls to create durable, lightweight structural components suitable for construction and industry.
The construction process of summer log houses by DREWNEX Dummy Drunian follows a structured approach, ensuring durability, functionality, and aesthetic appeal. The process consists of several key stages, from material selection to final finishing. Before the construction begins, the foundation is carefully prepared to provide a stable base for the log house. Depending on the project specifications and soil conditions, a concrete slab or strip foundation is typically used. Wall construction. The walls of the log house are made from high-quality wooden logs, precisely cut and processed. The logs are joined using traditional methods to ensure a secure fit and excellent insulation properties. Special corner notching techniques are applied to enhance stability. For added strength, the structure may include a wooden frame system, particularly in partition walls.
The roof structure of the summer log house is designed for both durability and aesthetic appeal. It features a visible rafter system constructed from visual grade, kiln-dried, and four-sided plain timber, ensuring a high-quality finish. The rafters and trusses provide structural integrity, supporting the weight of the roof while allowing for an open and spacious interior appearance. For insulation, the over-rafter insulation method is applied, where the insulating layers are placed externally, ensuring energy efficiency and thermal comfort. This technique minimizes thermal bridging and enhances the overall insulation performance of the roof. The standard roofing material used in these houses is metal roofing tiles, which provide durability, weather resistance, and a traditional look. Alternative roofing options include shingle-style metal roofing with a granulated coating for added texture, ceramic roof tiles for a classic appearance, and the Yanisic roof covering, which mimics traditional wooden shingles. The roof design allows for additional customization, including lighting integration within the visible rafters, and the option for prefabricated trusses to simplify the construction process. These elements contribute to both the functionality and visual appeal of the roof, ensuring it complements the overall log house design.
Windows and doors installation. The selection of windows and doors depends on whether the house is intended for year-round use or as a seasonal retreat. Standard solutions for residential houses include triple-glazed PVC windows, ensuring high thermal insulation. Recreational cabins are usually equipped with double-glazed windows. For wooden windows and doors, laminated pine wood is used. Doors are available in both standard designs and custom-made options. All windows are rectangular, with arched or decorative glazing bars available upon special request. Partition walls construction. Partition walls in the attic are built using a frame system covered on both sides with wooden facade boards or gypsum board on OSB panels. This system ensures structural integrity while allowing for effective insulation and finishing options. Interior wall finishing. Interior walls can be finished with wooden facade boards, typically 18 millimeters thick. An alternative option is using thicker plank-style boards, 28 millimeters. In bathrooms and kitchens, gypsum boards mounted on OSB panels are commonly used for better moisture resistance. Clients preferring a non-wood finish, such as stone, tiles, or clinker, require gypsum board cladding on OSB as a preparatory layer. Final touches and customization. Once the structural elements are completed, final customization options are implemented, including electrical installations, plumbing, flooring, and painting. Additional elements such as lighting fixtures, built-in furniture, and exterior landscaping are arranged based on the customer's preferences. DREWNEX Domidrunian ensures that each log house meets high-quality standards, blending traditional craftsmanship with modern construction techniques. The result is a durable, comfortable, and aesthetically pleasing summer log house tailored to individual requirements.
The process of making a Hiroshima chair in walnut with a clear urethane finish involves several steps. First, the walnut wood is carefully selected to ensure the best quality, without any defects. Then, the wood is cut into suitable sized panels and bars, and machined to form parts such as the chair frame, armrests, and chair legs. These details are assembled together precisely and firmly. Next, the chair is coated with a clear urethane layer, which protects the wood surface from environmental impacts, while highlighting the natural color and grain of the wood. After the paint is finished and dried, a layer of leather is processed on the chair to create a soft, luxurious, and comfortable feeling for the user. Finally, the chair is thoroughly inspected for quality. Any problems, if any, are repaired before being packaged and prepared for shipping to the customer. This push and blade splitter is a powerful machine designed to split wood into smaller pieces for firewood or other uses. After loading the wood onto the rack, the process begins with a push system, which feeds the wood into the splitting chamber. The system uses hydraulic or mechanical force to move the wood steadily into the correct position. Once the wood is in the correct position, a sharp splitting blade, usually a wedge-shaped blade, is activated to cut through the wood. The combination of the push system and blade ensures efficient and even splitting, reducing the physical effort of the operator and improving productivity. These machines are commonly used in both residential and industrial settings and can handle a wide range of wood sizes and types.
The first step is design and planning. The engineering team starts by taking a request from the customer or developing a door model according to internal standards. Technical drawings are created, including exact dimensions, style, sliding door, swing door, material type, natural wood, MDF, UPVC, steel, aluminum, and additional details such as hinges, locks, or decorative glass. Design software is often used to ensure accuracy and optimization before moving to production. Next is the preparation of raw materials. Depending on the type of door, the appropriate raw materials will be selected. For wooden doors, natural wood such as oak, pine, or MDF HDF panels are thoroughly inspected to eliminate defects such as warping, cracking, or dead eyes. For plastic or metal doors, UPVC plastic bars or steel panels are tested for durability and weather resistance. After selection, the raw materials are stored in warehouses with suitable temperature and humidity conditions to avoid deformation before processing. The cutting and rough machining steps take place next. The raw materials are fed into modern machines such as jigsaws and CNC machines to shape the main parts such as door frames, door panels, and trim strips. Accuracy in this stage is very important to ensure that the details fit perfectly when assembled. With wooden doors, the edges are smoothed to remove burrs. With plastic or metal doors, welds or cut corners are treated to increase durability. After rough machining, the product moves to the surface treatment stage. For wooden doors, the surface is thoroughly sanded, then coated with anti-termite chemicals and primer for protection. Depending on the design, the door can be painted, veneered, or laminated to increase aesthetics. With plastic doors, the surface is often treated with an anti-UV coating, while metal doors are powder-coated or galvanized to prevent corrosion. If the door has glass, the glass panels are cut to size and tested for fit. The assembly stage is the next important step. Parts such as the frame, door leaf, hinge, handle, and lock are assembled together. For special doors, such as soundproof or fireproof doors, additional materials, such as honeycomb paper, fiberglass, or rubber gaskets, can be added to increase performance. Accessories such as safety latches and escape bars, if any, are also carefully installed to ensure smooth operation. After assembly, the door is inspected for quality. Each product is thoroughly tested for durability, strength, impact resistance, tightness, water and wind resistance, and operability, opening/closing without jamming. Minor defects such as scratches and dimensional deviations are corrected immediately. If it is a specialized door, fireproof insulation, the product can be tested according to international standards such as ISO or ASTM. Finally, packaging and shipping. The door is wrapped with shrink film, adding corner protection with foam or cardboard to avoid damage during transportation. The product is then delivered to the customer or installation site, accompanied by instructions for use and warranty if applicable. This process reflects the combination of modern technology and craftsmanship, ensuring the supply of high-quality doors to meet the diverse needs of the market.
Building a floor truss involves several key steps to ensure durability and efficiency. First, engineers design based on load-bearing requirements and dimensions. Next, high-quality dry lumber of the correct length is selected and assembled into a form using a hammer. Joints are then used to secure the sections together. Once assembled, the trusses are transported to the construction site, where they are lifted into place and secured to the building frame. Each truss undergoes quality control to ensure structural integrity and proper dimensions. Forestry and woodworking is a vital industry that blends forest resource extraction with advanced processing techniques to produce a wide range of products for daily life and economic needs. The process begins with veneer peeling, a common woodworking technique where logs are fed into a peeling machine to create thin sheets, typically 0.5 to 3 millimeters thick. These sheets are then sawn into smaller sizes or pressed together with specialized glue under high pressure to form plywood, a durable, lightweight material widely used in furniture and construction. The pressing stage requires precision to ensure tight bonding between layers, preventing warping and enhancing strength. The process of producing veneer sheets begins with the selection and debarking of the wood. The wood is then steamed or soaked in hot water to soften it before being sliced or peeled into thin sheets. The veneer sheets are then dried, trimmed, and graded according to quality. Finally, they are planed, stacked, and packaged for use in the production of plywood, wood packaging, and furniture. The wood is cut into small pieces, dried to reach the standard humidity, helping to limit warping and termites. After processing, the wooden bars will be planed, joined with sawtooth joints, or joined horizontally with specialized glue. Next, they are pressed under high pressure to form large panels. After pressing, the panels will go through the process of sanding, cutting edges, and covering with protective layers such as PU paint or veneer to increase aesthetics and durability. Finally, the laminated wood panels will be quality checked before being packaged and shipped. This process helps to create durable, environmentally friendly products and is widely used in interior design and construction. Meanwhile, chipping and burning offers another processing avenue, often applied to wood scraps or waste. Wood is chipped into small pieces or sawdust, then compressed into fuel pellets or particle boards. These products maximize resource use, providing biofuel or affordable materials for furniture. The burning process also supports renewable energy production, minimizing forest resource waste. Wood turning combines craftsmanship with machinery, shaping wood on a lathe to create rounded components like table legs, chair legs, or handles. Skilled artisans use turning tools to achieve smooth, aesthetically pleasing finishes. This leads to the production of doors and windows, requiring sawing, mortise and tenon joinery, and surface finishing. Wooden doors, often made from hardwoods like oak or teak, feature sturdy joints and protective coatings, offering both durability and elegance. Wooden windows follow a similar process, typically paired with glass for enhanced beauty and functionality. Lastly, barrel making is a traditional craft, widely used for wine storage or goods containment. Wood is sawn into staves, steamed for bending, and tightly assembled with steel hoops. This process demands high skill to ensure watertight. Barrels are watertight and long-lasting. Forestry and woodworking through these processes not only preserve resource value, but also produce versatile products meeting needs from household to industrial applications.
Discovery Dream Homes specializes in the design and construction of custom log homes, offering a variety of log profiles and species to suit diverse preferences. Their process begins with naturally air-drying logs for at least 1 year before cutting, ensuring optimal quality. Once acclimated, the timbers are planed to the desired profile and size, then precisely cut and drilled using automated CNC machinery. The double tongue and groove profile provides a triple seal between log courses, enhancing the home's efficiency. An innovative adjustable thermo-spring through-rod compression system compresses the logs, eliminating the need for manual tightening. Electrical box allowances and pre-drilled wire chases are integrated into the logs, reducing on-site labor costs. Each home is pre-assembled in the factory for quality assurance before being disassembled and packaged for delivery. The production process of wooden chairs at the factory involves several key stages. First, the design team creates detailed blueprints for each chair, selecting high-quality wood for durability and aesthetics. Next, the wood is cut into the required shapes and sizes, followed by sanding, which is done using a combination of machinery and manual labor to ensure smooth surfaces. After shaping, the wooden parts are coated with a protective finish, using both machine and manual methods for a smooth, durable layer. Then, fabrics or leather are cut and wrapped around the wooden frame, combining manual work and machines for a tight, attractive finish. Finally, each chair undergoes a quality control inspection to check for defects. Once approved, the chairs are packaged and prepared for delivery. This process ensures that each wooden chair meets high-quality standards for both design and functionality.
The Albach Diamant 2000 is one of the most powerful self-propelled wood chippers, designed for high efficiency and durability in demanding environments such as biomass power plants. Equipped with a MAN 790 PS engine, this machine can process 330 to 350 cubic meters of material per hour, making it an essential component in a 2.9 megawatts wood chip power plant. Its advanced design ensures high productivity while maintaining superior chipping quality. The machine operates with a permanent all-wheel drive system, featuring an independent hydromechanical drive on both main axles. This system provides excellent maneuverability, allowing it to navigate and function efficiently on rough or sloped terrain. With its ability to handle challenging environments, the Diamant 2000 ensures continuous operation without interruption. At the core of the Diamant 2000 is its high-performance rotor, which has been continuously improved for optimal efficiency. This rotor enables the production of wood chips ranging from 9 mm to 60 mm in size. The replaceable knife carriers automatically adjust to different types of materials, ensuring the best possible chipping results. Additionally, the latest rotor generation features diesel and power-saving technologies, enhancing overall efficiency. Customers can request technical modifications based on their specific needs. Several innovative features make the Diamant 2000 particularly user-friendly and efficient. It has a road-legal design, allowing transportation at speeds of up to 80 km per hour. A pneumatic differential lock ensures better traction, while the chain-free drive system minimizes wear and maintenance. The quick-change counterblade system simplifies servicing, reducing downtime. Another key advantage is the ability to drive and chip simultaneously, eliminating the need for repositioning. The hydraulic accelerator ensures controlled feeding, while the crane with a 10.1-meter reach enhances material handling efficiency. Edward Wall creates exquisite custom furniture and cutting boards through a woodworking process rooted in craftsmanship and precision. Working from his shop in Spring Green, Wisconsin, he carefully selects premium woods, particularly bird's eye maple, for their unique grain patterns. Each piece is designed with simplicity in mind, balancing Scandinavian and Shaker influences. Wohl employs traditional woodworking techniques alongside modern tools, refining every surface to a flawless finish. His process includes model making to perfect proportions before crafting furniture, while cutting boards undergo extensive sanding and oiling. His dedication to quality ensures each piece is both functional and visually stunning.
The ZSH-30 screw mill provides significantly improved wood chip quality with a lower proportion of fines. Simply feed large logs into the mill and the mill produces small, uniform wood chips. The design of the machine ensures that the wood is processed efficiently, maintaining a high level of uniformity in chip size. While minimizing excessive fines. This results in better combustion efficiency in power plants, reducing waste and maximizing energy output.
At Linda's mill, the process of milling oversized logs requires innovative methods. In this part, a massive oak log, previously split using black powder, undergoes precision cutting with a wood-miser sawmill. This method ensures that logs too large for standard milling can still be processed effectively. The video showcases the first half of the split log being milled. While the full operation takes nearly 40 minutes, key moments have been edited to fit within 15 minutes. The wood-miser mill, known for its accuracy and efficiency, handles the heavy oak section smoothly. Each pass of the saw carefully transforms the rough split wood into usable lumber. The consistent feed rate and sharp blade ensure clean cuts, reducing waste and maximizing yield. This process highlights the combination of traditional and modern techniques, using black powder for splitting and a portable bandsaw mill for refining the wood. By utilizing these methods, Linda's sawmill efficiently processes large timber that might otherwise be unmanageable, demonstrating both craftsmanship and ingenuity in custom lumber production. The wooden frame house construction industry in Russia is flourishing, holding about 20 to 25% of the individual housing market, with an annual output of 80,000 to 100,000 units in 2025. Small homes, like a 35 square meters, 5 by 7 meter design, are favored for their affordability and speed. Using pre-manufactured frames and panels, these houses can be completed in 10 to 20 days. Assembly often takes under 2 weeks, with basic finishing following shortly after. This efficiency suits the growing demand for quick, cost-effective housing. Construction costs range from $220 to $400 per square meter, totaling $7,700 to $14,000 for a 35 square meters home. Pine and spruce, making up 70 to 80% of frame timber, cost $120 to $150 per cubic meter. Walls commonly use OSB, oriented strand board, a pressed wood product from pine or spruce strands, priced at $6 to $10 per 1.22 x 2.4 4-meter panel, 9 to 12 millimeters thick. This durable, lightweight material supports rapid assembly, mirroring the pressed wood seen in construction videos, and keeps costs low while ensuring strength. The sector employs over 150,000 workers across approximately 2,000 small and medium enterprises, producing 1.5 to 2 million square meters of prefabricated housing yearly. Government support, including rural housing subsidies exceeding $500 million in 2024, drives expansion. These homes excel in energy efficiency, reducing heat loss by 30 to 40% compared to brick buildings, thanks to insulation like mineral wool, 100 to 200 millimeters thick, and double-glazed windows, $50 to $80 each. Despite a 10 to 15% rise in timber prices since 2023, due to export restrictions and a skilled labor shortage in remote regions, slowing growth by about 5% annually, the industry remains resilient. The combination of prefabrication, affordability, e.g., $7,700 for a small home, and sustainability ensures a bright future, meeting Russia's rising need for efficient housing solutions. Cedar peeling machines work by feeding logs into the machine, rotating or moving the logs under a blade system to strip the bark and outer wood layers, leaving a smooth, even surface. The machines usually have a rotating drum or a fixed blade system to peel the wood in a controlled manner, ensuring even peeling. These machines are typically designed to handle large logs and are used in the production of smooth, high-quality lumber, suitable for a variety of applications. The production process of OSB Ultralam, oriented strandboard of Talian Terra, Russia, begins with raw material preparation. Plantation wood such as pine is peeled, chopped into thin chips, 100 to 150 millimeters long, 0.5 to 1 millimeter thick, and dried at 200 to 250 degrees Celsius to a humidity of 2 to 4%. The wood chips are then mixed with waterproof glue, phenol formaldehyde or MDI, and additives in a mixer. The orientation step arranges the chips into 3 to 5 layers, outer longitudinal, inner transverse, using an automatic spreader, then hot pressed under a pressure of 20 to 30 kilograms per square centimeter for 5 to 10 minutes, creating a 6 to 25 millimeters thick panel. Finally, the panel is trimmed, sanded, and quality tested for durability and humidity, meeting OSB 3 and OSB 4 standards. This process is optimal, environmentally friendly, producing durable materials for construction and interior design. The framing process of a detached garage begins with laying the foundation and constructing the floor system if required. Once the foundation has cured, pressure-treated sill plates are anchored to the concrete, providing a secure base for the wall framing. Wall framing consists of assembling and erecting stud walls, typically using 2x4 or 2x6 lumber spaced at standard intervals, such as 16 inches on center. Openings for doors and windows are framed with headers to distribute the load above. Once the walls are squared and plumbed, they are secured to the sill plates and temporarily braced. After the primary framing is complete, exterior sheathing is applied to the walls to improve structural integrity and prepare for siding. The framing process is finalized with additional bracing, blocking, and verification of all load-bearing elements to ensure the garage is structurally sound and ready for further construction stages. Next, the roof structure is installed, starting with the placement of ceiling joists and rafters, or prefabricated trusses, depending on the design. Roof sheathing, usually plywood or OSB, is then nailed in place to create a sturdy base for roofing materials. Revo produces around 100 windows a day, serving customers all over France. Among their standout products are the Excellence Mixed and Excellence Bois window ranges, which offer better thermal performance, with an aluminium outer layer that reduces maintenance and an inner layer of wood protected by a quality paint. Since 2005-2006, the window market has started to move towards thicker profiles to improve thermal performance, and Revo has started to look for new solutions to meet the 2012 and future thermal standards. They have learned from the Eastern and Northern European markets, participated in fairs and contacted machinery manufacturers to improve their production technology. The WRC 1250 AC horizontal bandsaw is a specialized machine designed for high-productivity sawmills, offering fast and precise cutting. It is engineered to optimize wood processing, featuring a continuous monitoring system with live video and visual imagery, allowing operators to easily track the process. A standout feature is its ability to pre-cut according to the log's shape, maximizing material utilization. The machine operates with a manual board-pushing guide mechanism, enabling quick and flexible handling of large logs. Its robust rail system, made from hardened welded materials, combined with a mobile log turner, reinforced supports, and high-driven rollers, ensures exceptional durability and stability. In terms of technical specifications, the WRC 1250 AC boasts a main wheel diameter of 1250 mm and a width of 135 mm, capable of cutting logs with a maximum diameter of approximately 1,250 mm. The saw blade measures 9,045 mm in length and 160 mm in width, allowing a maximum board thickness of 340 mm. Powered by a 45/55 of a kilowatt motor with an electric brake and inverter, it achieves a cutting capacity of up to 55 cubic meters in 8 hours. The maximum head frame height is 1,150 millimeters, suitable for sawmills with a width of 6,500 centimeters and a total height of 4,400 to 4,600 centimeters. This machine is an ideal choice for professional wood processing facilities. The production of Klassen plywood involves several key processes, starting with the use of a drum chipper to break down raw wood into small chips. These chips are then subjected to a boiling process using water vapor, which helps soften the wood fibers for further processing. Next, the fibers go through gluing and fiber drying stages, ensuring the right consistency and strength. The HDF board is delivered after drying. The next step involves preparation of surfaces to ensure they are smooth and ready for further treatment. Adhesive application is followed by the decorative paper application, which is applied to the surface to create the desired aesthetic. The digital printing process allows for intricate designs and patterns to be printed directly onto the board. Afterward, the melamine resin is used to ensure durability and resistance to wear. Embossing is done to add texture, followed by profiling, which shapes the edges of the plywood. The boards are then moved through the logistics and packaging stages, preparing them for shipment. Finally, the finished goods are stored in the finished goods warehouse. The reed mat making machine is an effective solution for businesses, helping to pay for itself in less than 3 months. With a simple and easy-to-use design, the machine allows 3 people to produce 20 to 25 mats in a working day without much effort. The operation process is very easy. Just load the reeds and materials into the machine, set the technical parameters such as mat size and reed length, then the machine automatically performs the entire process from weaving the reeds to forming the finished mats. The machine saves labor costs and improves productivity, making it an ideal choice for businesses that want to grow rapidly without investing too much resources. The LS18 wood splitter comes in different variants, including pure PTO models or the combined PTO 400 volts versions. Available in 13, 18, and 25-ton models, it offers flexible power options, either through a PTO drive or a 400 volts motor. The machine features both forward and reverse operation, with a large working stroke of the splitting piston. For safety, it requires two-hand operation, ensuring secure use. The splitter can be returned either manually or automatically, offering convenience. Compact and mobile, it can be easily prepared for operation, with the cylinder retracting for portability. Additionally, the machine includes a wood lifting device for efficient handling and has been TÜV/GS certified for reliability and safety. The Kretzer Rotomat wood cutting machine, mounted on a trailer, is designed for efficient firewood processing. It cuts logs into 25 centimeters lengths with precision. The drive is powered via a 16A power connection, utilizing a screw fuse for safety. This machine is capable of producing approximately 4 to 5 cubic meters of firewood per hour, making it a highly efficient choice for those needing to process large volumes of wood quickly. Its robust construction and efficient design ensure reliable performance, making it ideal for firewood producers and forestry operations. The SpaltFix K700 Vario is a modern firewood production machine designed to process logs with a maximum diameter of up to 70 centimeters. With its outstanding power, the machine has a maximum separation capacity of 19 tons, ensuring efficiency even with the thickest and hardest logs. The impressive speed of the SpaltFix K700 Vario allows the production of 27 cubic meters of firewood per hour, making it one of the fastest machines in its class. The machine is equipped with a 100 centimeters long saw bar and a hydraulic double clamp in the supercut unit, ensuring safe and precise cuts, even with wood with a minimum diameter of 15 centimeters. Users can easily adjust the length of the firewood edge from 5 to 15 centimeters, flexibly producing different types of firewood according to their needs. The highlight is the auto feed feature, which allows fully automatic loading of wood in 1.5 hours, optimizing the workflow. The SpaltFix K700 Vario is not only powerful and fast, but also offers convenience and high performance, making it the ideal choice for professional firewood production. The CBI Magnum Force 6400 CT horizontal grinder is a high-performance, heavy-duty machine designed for grinding tough materials like demolition debris, whole trees, pallets, and stumps. Built with a fully welded hog box, it delivers unmatched durability and efficiency. It features 4 interchangeable rotor options: segmented drum, forged drum, 2-pocket chipper, and 4-pocket chipper, providing flexibility for various applications. Powered by a Cat C27 engine, 1050 HP, with an optional Cat C32 upgrade, 1200 HP. It handles demanding workloads efficiently. The machine weighs 40,823 to 47,173 kilograms, with working dimensions of 3.28 meters times 16.2 meters times 4.65 meters. Its cassette-style clamshell design enables fast rotor swaps, reducing downtime and increasing productivity. With its powerful engine, adaptability, and innovative design, the 6400 CT is a top choice in the horizontal grinder market, ensuring high efficiency in diverse material processing tasks. The production of particle board, chipboard, is a complex process that maximizes the use of wood waste from plywood manufacturing, such as defective veneer, pencil wood, and other scraps. First, these raw materials are crushed into wood chips, with oversized firewood processed separately in a disc chipper for uniform sizing. The chips are then screened to remove oversized particles, ensuring a consistent raw material supply. Next, the chips are transported to storage silos before being refined into fine wood shavings, which are then dried in drum dryers to reduce moisture. After drying, the shavings are further processed in hammer mills and sorted into 4 categories: dust, shavings for the outer and middle layers, and coarse particles. These sorted shavings are mixed with binding agents to create resin-impregnated material, which is then evenly spread onto trays moving along a conveyor to form layered mats. These mats undergo cold pressing for preliminary shaping and are weighed for quality control before entering the hot press, where high temperature and pressure solidify the boards. After pressing, the boards are cut to standard sizes, stacked, and left to cool for 24 hours before being sanded for a smooth finish. Some boards undergo additional lamination, where decorative films are applied and pressed onto the surface. The final product is inspected, sorted, packaged, and stored for shipment. Throughout the process, strict quality control measures ensure that the boards meet industry standards, with laboratory tests assessing strength, density, moisture content, swelling, and toxicity. Every batch receives quality certification, ensuring compliance with international regulations.